Okay, so what we're going to do today is limits. What is a limit? A limit is the number a function approaches at a certain spot. So the way you write a limit, first of all, is like this, limit, and then we can do as x approaches a number. For this graph on the left, we'll say as x approaches 2. So we're trying to figure out what x is and what the function f of x is as x approaches 2 on the graph. From the graph, you can see that x at x equals 2, it's about 3. So the limit is 3. In this scenario, though, f of 2 is also 3. But if we just get rid of the part where x equals and where y equals 3 in the graph, where x would be 2, the limit as f of x and as x approaches 2 of f of x, this is still 3 because the graph on both sides is approaching the value 3 at x equals 2. However, f of 2 in this case is undefined, which is like this, because there is no value there at f of 2 because there's a hole in the graph. And that's pretty much the basics of limits. Okay, now we can do some practice problems with limits. On the right is a graph of f of x, and we're going to fill out these, starting with the limit as x approaches 1. So we go to the graph, we see where x is 1 is, see where the graph is going. In this case, it's going towards the value -1. Even though there's a hole in the graph, it doesn't matter because the function is approaching -1. So the answer is -1. F of -3, we go to x is -3, and we see that even though the graph approaches this value, it's the actual point. So f of -3 is 0. Let's write that down. Next, the limit of f of x as x approaches 2. We see that the graph is approaching the value of 2 at the x value of 2. Even though there's a point at y equals 3, the graph is approaching 2. Now f of 2, we talked about this, even though the graph is approaching 2, is the actual value. So f of 2 is 3, which is different from the limit in this case. That's a pretty bad 3. Now f of 1, go to x equals 1. F of 1 has no point here, so it's undefined. F of -2, 1, -2, it's just positive 2, so a point on the graph. The limit as x approaches 0, go to x equals 0, go down, it's just -2. The graph is going towards -2 on both sides. And lastly, the limit as x approaches -3, the graph is going towards +1, even though the value is 0. The answer to the limit is 1, because that's where the graph is approaching. And that's it for the practice problem. Okay, now, the question becomes, what if you have a graph like this? What is the limit at x equals 3 in this case? Because the graph on the left side is going towards -1, but the graph on the right side is going towards +3. So how do we explain the limit in this graph? So what we do is we can specify which direction a limit is coming from. So first, the limit as x approaches 3, we write that. But then if we want to specify if it's from the left, we add a minus on the top. So the limit as x approaches -3 from the left of f of x is going to be -1, because on the left side, that's where it's approaching. It's approaching -1. But if you want to specify from the right, then you do as x approaches 3 with a plus of f of x. And then on the right side, the value is +3. But if you want to say the limit in general as x approaches 3 of f of x, let me just write it down. This does not exist. So you just say d and e does not exist because the graph, there's no connection, so there's no common limit. Okay, I made up a practice problem real quick. Now let's start with over here. The limit as x approaches 2 on the right side. We can see that the graph is going down towards negative 1, 2, 3, 4. So the limit as x approaches 2 on the right side is negative 4. On the left side, the graph is going up as x approaches 2 on the left is at positive 2. Since these two values are different, the limit at x at the limit of x as it approaches 2 for the whole function does not exist. So d and e does not exist, but f of 2 is still the value 2 because there's a point here that the value is 2. So that's it now for the practice. Okay, for this lesson, the last thing we're going to have to do with limits is use tables. So for this problem, you're not going to see a lot of the problems like this on like quizzes and tests. You just got to know this. You got to see that the table, we're asked as the limit as x approaches 3, and we can see the table has values of 2.9, 2.99, 3.01, and 3.1. So we're going to try to find the limit as x is 3. We can see from the values of 2.99 and 3.01 that x is becoming really close to 4 because the values are 3.99 and 4.01. So limit as x approaches 3 is 4. Okay, so lastly, sometimes you're going to be given the function, you have to make the table yourself to figure out the value as x approaches a certain value. In this case, it's going to be the limit as x approaches negative 2 because that in that area it's undefined. Negative 2 of f of x. And what we do to solve this is we just pick some values around negative 2. So what I did is I chose negative 2.1, negative 2.01, negative 1.99. Ooh, that's a bad 9.99, and negative 1.8. And what you just got to figure out the values of f of x for the values of x and see what number is being approached on either side. And I already did the math, so for this it's 22.01. For this it's 21.01. For this it's 20.99. And for negative 1.8, it is 20.01. And you can see as it's approaching negative 2, the value is approaching 21 because on both sides it's going closer to 21. So the answer to this is 21. Sometimes though you'll have different values being approached, so the limit might not exist, but it might exist from the right side or the left side, so you just have to be careful of where you're looking.